It's been a hot minute since my last video. I just started taking organic chemistry this semester and I am packed. This is like the perfect subject to do in Minecraft since it's all like three-dimensional blocks and like you could just build that out and explain. But I don't know chemistry. I'm so bad at chemistry. If you tell me any chemistry problem, I will get it wrong, which is ironic since I'm a biology major. I'm trying to get my master's degree in ecology and evolution, but chemistry is just no for me. No. The issue is I have to take organic chemistry in order to get my degree, but I don't know chemistry at all. Even the basics are like new to me. And so I was gonna make this series to learn organic chemistry in Minecraft and you can learn with me, but I want to make a disclaimer that I don't know this subject. In my biology videos, at least I am aware of biology. I know biology, I love biology. But with chemistry, it's different. I don't know this, and I would try my best to make a video that's educational, but I don't feel confident in that. So I guess I'm gonna make a new series where you can learn organic chemistry with me and watch me struggle. Now, this is not really a video or a playlist made to learn organic chemistry. I don't recommend it. There's so many better resources out there like Organic Chemistry Tutor, Crash Course, and Professor Dave. But I wanted to put my own little video out there just for me. More so like as a way during my finals exams, I can just rewatch how I learn as a recap, so hopefully I can like pass this class is my hope. With this in mind, when I'm explaining topics, it's more so me reading off of a book and quill because I can't really explain to you organic chemistry. I've tried my best preparing for this one short video, but I'm like, it's gonna be too hard. It's too hard. If you have any like resources in the comments, I would love that. I would really appreciate it, but right now, I can't. This is the best I can do, and really, I'm just going with the flow as well. So this is more so to teach myself organic chemistry instead of teaching others. Before I show you what I have created over here, I'm going to give you some definitions that will be useful in understanding what I'm trying to explain. The structure, all of these definitions I got from my textbook at my university, so hopefully they're correct, you know? It's just definitions they've given me, so these are correct. My explanation to them may not be right. The structure is an organizational pattern or arrangement of parts that characterize a thing. In organic chemistry, this is a manner in which atoms compose a molecule. So I guess the different structures you have. Composition is the kinds and numbers of atoms that compose a molecule of a compound. So maybe in a composition there's 3 atoms, or maybe you have 4 atoms. It's how many atoms in a compound. Constitution, manner in which the component atoms of a molecule are bonded to each other. So how they are found, how they are shaped. Different compounds having the same composition but different constitutions are isomers. The prefix iso means the same or alike. So maybe they are made up of 4 atoms, but they're in a different arrangement among those 4 atoms. Configuration is the shape of a molecule in a 3-dimensional space. Isomers that differ only in configuration are called stereoisomers. Alright, that's all the vocab. I know, I wish I could explain it better without just reading it off a piece of paper, but that's all I can do right now. Hopefully, by the end of the series, maybe I'll be better at it. We will see. I don't know. So let's take this cube, for example. This cube will represent an atom, okay? But let's just think about it in cubes because I hate thinking about it in terms of atoms. This cube has 6 faces. So what I mean by that is this is a face, another face, this is 2 faces, 3 faces, 4 faces, 5 faces, and 6 faces. So as you can see, one cube has 6 different faces. Up to 6 other cubes can attach to the given cube. So let's say this stone button is a cube. So that means another cube can attach, another cube can attach, another one can attach, etc. You know, they can just all attach with each other. So wherever there is a face on the cube, that's where another cube can attach to. The more cubes we use, the more structures we can make. 4 cubes are up ahead. Only 8 shapes can be made. So as you can see, these are only 4 cubes. 1, 2, 3, 4. Okay, 4. Each of these structures only use 4 of the cubes. I separated each group using a line, but if we go to group 1 is defined as 2 cubes have 2 cubes connecting to them. So for example, these blue cubes will have 2 cubes connecting to their face. So as we said before, each one of these is the face of the cube, right? We agreed that there's 6 faces on the cube. And so, as you can tell, this blue cube right here has 1 cube attached to its face, and now 2 cubes attached to its face. So all the blue cubes in this arrangement has 2 cubes attached to its face. You can see it right here. This cube has 2 cubes attached to its face. Same with this one. This cube has 2 cubes attached to its face. Same with this one. You see this cube has this cube attached and this cube attached. And this cube has this cube attached and this cube attached. Same with this one. Now, as you can tell, these 2 cubes are reflecting on each other. The shapes are reflecting. It's almost like if you had a mirror right now and it mirrored the image. And that is actually defined as, oh god.
Enantiomers.
Enantiomers.
Enantiomers. Wow, enantiomers. So these things are enantiomers. That's weird to say. They mirror each other. Okay. Yeah, okay, so these are stereoisomers. Remember the isomers are like the same, but they different. Like, they're made up of the same blocks, right? You have 4 blocks, right? They're made of the same blocks. They're the exact same 4 atoms, but they're different in shapes. Like, oop, that's still 4 blocks, or oop, that's still 4 blocks, that's still 4 blocks. But they're the exact same component. They have the same 4 blocks, but they're just a different shape. That's an isomer. Stereoisomers are different versions among a group. So you see how this is a group 1, but inside of group 1, you have different versions of it. That's a stereoisomer, I think. I'm pretty sure. Hopefully. Group 2, these should also be stereoisomers. How you can see they are different things. And then group 3, that I have not learned much about yet because I just started this class today. This is a very short video, just as an introduction to this series. Hopefully it gets better. Hopefully I get more confident in making these videos and explaining, and hopefully I will start understanding organic chemistry as someone who does not understand chemistry at all. We hope. My class is like 90% of exams and finals. That's the only thing we get graded for. Homework is like 5% and that's it. So I hope this series works. If you have any recommendations in the videos, please let me know. If you want me to continue this, please let me know. I'm also taking ecology, evolution, genetics, weight training, and I have a job on the side as a biology front desk person. So if any of those topics sound fun to you and you're like, oh my god, Addie, teach evolution, please let me know and I will make a video over that. But yeah, I am busy, super busy, but I hope this explains something for someone who's like me and can't understand some of this stuff. But yeah.